or how do you identify the acceleration displacement graph from the given velocity displacement graph? Hello my dear students, so welcome back to Basil's physics classroom. In today's class, we'll be learning about graphical representation of one-dimensional motion. In the last class, we learned about the basic idea and I have taught you some shortcut equations for one-dimensional motion. If you have not watched it, do go back and watch it and then come back to graphical representation of one-dimensional motion. Okay? അപ്പോൾ നമ്മൾ പ്രധാനമായിട്ട് മൂന്ന് ഗ്രാഫ്സ് ആണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്. ഒന്ന്, we'll be learning about xt graph or the position time graph. രണ്ട്, we'll be learning about vt graph or the velocity time graph. And മൂന്ന്, we'll be learning about at graph or acceleration time graph. Okay? മൂന്ന് ഗ്രാഫ്സ് ആണ് നമ്മൾ പഠിക്കാൻ പോകുന്നത്. ഏതൊക്കെയാണ്? Position time graph, velocity time graph, acceleration time graph. Okay? അപ്പോൾ ഗ്രാഫിലേക്ക് ഡീറ്റെയിൽ ആയിട്ട് പോകുന്നതിന് മുമ്പ് ഒന്ന് രണ്ട് കാര്യം പറഞ്ഞോട്ടെ. The slope of an xt graph will give you velocity. The slope of a vt graph will give you acceleration. ഓർത്തിരിക്കുക, slope of xt graph gives you velocity, slope of vt graph will give you acceleration. Okay? ഇനി നേരെ തിരിച്ച്, area under at graph gives you change in velocity. എന്താണ്? Velocity അല്ല, change in velocity. Area under vt graph will give you displacement. എന്താണ്? Displacement. അതേസമയം if it is a speed time graph, you can get distance. ഇനി velocity time graph നിന്ന് നമുക്ക് ഡിസ്റ്റൻസ് കണ്ടുപിടിക്കാം കേട്ടോ. നമ്മൾ ഗ്രാഫ് വരയ്ക്കുമ്പോൾ ഞാൻ അത് പറഞ്ഞുതരാം. Okay? So slope of xt graph gives you velocity, slope of vt graph gives you acceleration, area under at graph gives you change in velocity, area under vt graph gives you displacement. Okay? അപ്പോൾ നമ്മൾ ആദ്യം പഠിക്കാൻ പോകുന്നത് പൊസിഷൻ ടൈം ഗ്രാഫ് അല്ലെങ്കിൽ xt graph ആണ്. So xt graph. First situation is when a body is at rest. When a body is at rest, how do you draw the position time graph? A body restilana, which means with respect to time, there is no change in the position of the body, like state of rest. Which means suppose initially the body was over here, then as the time progresses, again the body's position is not changing, it is remaining a constant with respect to time. Time കഴിഞ്ഞു, പക്ഷേ the position of the object is not changing. So it is a line parallel to the time axis over here. Now we can also draw it like this, no problem. Okay? Now, അപ്പോൾ at rest ആണ് നമ്മളിപ്പോൾ പറഞ്ഞത് അല്ലേ? അപ്പോൾ നിങ്ങൾ ഇവിടെ ഓർക്കേണ്ട ഒരു വെരി ഇമ്പോർട്ടന്റ് പോയിന്റ് നമ്മളൊരു ഗ്രാഫിക്കൽ റെപ്രസെന്റേഷൻ വരയ്ക്കുമ്പോൾ എപ്പോഴും ഓർക്കേണ്ടത് നമ്മുടെ ഫ്രെയിം ഓഫ് റെഫറൻസ് അല്ലെങ്കിൽ കാർട്ടീഷ്യൻ കോർഡിനേറ്റ് സിസ്റ്റത്തിന്റെ ഒറിജിനില് ഒരാളിരുന്നാണ് ഈ മോഷൻ മൊത്തം ഒബ്സർവ് ചെയ്യുന്നത്. വി കൻ കോൾ ഹിം ആസ് ദി ഒബ്സർവർ. അപ്പൊ ഈ ഒബ്സർവറിന്റെ ഒബ്സർവേഷൻ ബേസ് ചെയ്താണ് നമ്മൾ ഈ പറയുന്നതെല്ലാം. Okay, when the observer is also in motion, we arrive at the concept known as relative velocity. Okay, right. I'm not going to that right now. So coming back, at rest angle, this is the situation, or it can be along the time axis also, no issues. Okay. Now, if an object is moving with a uniform velocity, then the graph will be something like this. Or the graph can be something like this, no issues. So this is a case of an object moving with a uniform velocity. But ഞാൻ വെറുതെ uniform velocity എന്ന് പറഞ്ഞാൽ how can you prove that? അത് prove ചെയ്യാൻ we have to look at the slope of the graph. We know that the slope of xt graph gives you velocity. അല്ലേ? xt ഗ്രാഫിന്റെ സ്ലോപ്പ് നമുക്ക് velocity തരും. അപ്പോൾ നമ്മൾ ഇവിടുത്തെ തീറ്റ നോക്കുമ്പോൾ തീറ്റ, ഇവിടുത്തെ തീറ്റ നോക്കുമ്പോൾ തീറ്റ, the angle is the same, and you know that slope എന്ന് പറയുമ്പോൾ it is actually equal to tan theta. Slope എന്ന് പറയുമ്പോൾ it's actually equal to tan theta. അപ്പോൾ theta value constant ആണെങ്കിൽ we can say that if theta is constant, tan theta is constant. If tan theta is constant, velocity is constant, and therefore the graph represents a uniform velocity or the graph of a uniform motion. Okay? In non-uniform velocity ആണെങ്കിലോ maybe something like this. ഇങ്ങനെ കിടക്കും. അപ്പോൾ ഓരോ പോയിന്റിലും if you take the angle, it will be different. അല്ലേ? So that is a representation of a non-uniform velocity in an xt graph. Okay, clear ആണല്ലോ? ഈ നോൺ യൂണിഫോം വെലോസിറ്റി എന്ന് പറയുമ്പോൾ രണ്ട് സിറ്റുവേഷൻസ് മെയിൻലി വരാം. ഒന്ന്, ഇറ്റ് ക്യാൻ ബി ആക്സിലറേറ്റിംഗ് ഓർ ഇറ്റ് ക്യാൻ ബി ഡീസലറേറ്റിംഗ്. ഓക്കെ, അപ്പൊ ഞാനിവിടെ ഒരു ഗ്രാഫ് വരയ്ക്കാൻ പോവാ. യു ടെൽ മീ വാട്ട് ഇറ്റ് ഇസ്. xt ഗ്രാഫ് ആണ് വരയ്ക്കുന്നത്. Is this acceleration or deceleration? Most of you will give me the answer as acceleration, I believe. And what is this graph? Is it acceleration or deceleration? Is it acceleration or deceleration? And what about this graph? Another xt graph I'm drawing here. Is this acceleration or deceleration? And another xt graph I'm drawing here. Is this acceleration or deceleration? Okay, അപ്പൊ ഈ നാല് ഗ്രാഫ്സും ഇങ്ങനെ വന്നു കഴിഞ്ഞാൽ അത് ആക്സിലറേഷൻ ആണോ ഡീസലറേഷൻ ആണോ എന്ന് how do you identify? And that process is actually very simple. Let me teach you how. Now ഇവിടെ ഇതിന്റെ സ്ലോപ്പ് നോക്കിയാൽ നമുക്കറിയാം, the slope of xt graph will give you velocity. Okay, slope of xt graph gives you velocity. അപ്പൊ ഇവിടെ നമുക്കൊന്ന് തീറ്റ മാർക്ക് ചെയ്ത് നോക്കാം. അപ്പൊ ഇവിടെ ഒരു ചെറിയ തീറ്റ, ഇവിടെ ഒരു വലിയ തീറ്റ, ഇവിടെ വലിയ തീറ്റ, ഇവിടെ ഭയങ്കര വലിയ തീറ്റ അല്ലെ? As you can see, the value of theta is increasing. If the value of theta is increasing, tan theta is increasing. But tan theta is increasing means the slope or the velocity is increasing here. But velocity increasing anangil, this is an acceleration. Yes, you guessed it right. This is the curve representing an acceleration. Now, ഇവിടെ വരുമ്പോഴോ ഇവിടെ നമുക്ക് തീറ്റ നോക്കാം. Theta tangent and the horizontal angle between the tangent to the motion and the horizontal. ഇവിടെ ചെറിയ തീറ്റ, ഇവിടെ ഒരു വലിയ തീറ്റ, ഇവിടെ കുറേ കൂടി വലിയ തീറ്റ, ഇവിടെ ഒരു ഗമണ്ഡൻ തീറ്റ. Right? So what is happening here? ഇവിടെയും theta is increasing. If theta is increasing, tan theta will be increasing. If tan theta is increasing, velocity is increasing. And again, this is an acceleration curve. Acceleration. Okay, this is not deceleration. Don't mistake this graph when you see this. This is actually an accelerated graph. Okay, now this graph noka again theta noka. ഇവിടെ ഒരു വലിയ തീറ്റ, ഇവിടെ ഒരു ചെറിയ തീറ്റ, ഇവിടെ പീക്കിൽ തീറ്റ, ഇവിടെ കുഞ്ഞു തീറ്റ. So what is happening here? Again, the theta is decreasing. Theta കുറഞ്ഞാൽ tan theta കുറയും. Tan theta കുറഞ്ഞാൽ velocity കുറയും. അപ്പോൾ ഇത് deceleration. Method മനസ്സിലായോ? Okay, and this one, big theta, small theta, ചെറിയ theta, and even smaller theta. Theta is again decreasing. Theta കുറഞ്ഞാൽ tan theta കുറയും, velocity കുറയും, and the deceleration. And don't mistake this for acceleration curve. Okay, അപ്പോൾ നമ്മൾ നാല് രീതിയിൽ xt ഗ്രാഫ് യൂസ് ചെയ്ത് acceleration deceleration curves നമ്മൾ എക്സ്പ്ലെയിൻ ചെയ്തു. Okay, അപ്പോൾ please remember this, the slope of xt graph will give you velocity. ഏറ്റവും എളുപ്പത്തിൽ അത് acceleration ആണോ deceleration ആണോ എന്ന് കണ്ടുപിടിക്കാൻ സ്ലോപ്പ് നോക്കിയാൽ മതി. You will get some idea. Okay, right. So let's move on to the next graphical representation, and that is about the VT graph. Velocity time graph. Velocity time graph. Okay. അപ്പോൾ ആദ്യം വരയ്ക്കാൻ പോകുന്ന velocity time graph for an object at rest. Now at rest, when a body is at rest, its velocity will be what? Its velocity will be 0. If a body is at rest, we can represent the velocity time graph like this. Here, the velocity is equal to 0. And if the velocity is equal to 0, that will correspond to the velocity time graph of a body at rest. It will be through the time axis we'll have to do. Okay. Now, suppose the object is moving with a uniform velocity. Uniform velocity, then the VT graph will be. Then the VT graph will be. Is this the graph? Tell me, is this the graph for an object moving with a uniform velocity? Is it? As you can see here, the velocity is actually increasing with time. If it is uniform velocity, The velocity should not be increasing, it should remain a constant, right? So here the velocity is increasing with respect to time, so that is not the graph. How should the graph be? It should be a constant, and this is a corresponding graph. The velocity is a constant, and then we call it as a uniform velocity, moving with a uniform velocity, or the motion is a uniform motion. Okay. Now the third one, an object moving with an acceleration. With an acceleration, we can represent it like this. 1. As you can see, the slope, we can take a slope over here, and the slope is constant here, which means the acceleration is a constant. So this is a VT graph representing a body moving with a constant acceleration. Now, the graph need not always start from the origin. It can start from any other point, okay. No issues like that. Okay, so this is a case of an object moving under constant acceleration. Now, if it is retardation or deceleration, the slope will be something like this. Okay, it will be a negative slope, indicating that it is a retardation taking place here. Okay, so this is a positive slope and this is a negative slope. Okay, so this can represent retardation. Now, if it is moving with non-uniform velocity, how will you represent the graph? Non-uniform. Non-uniform means velocity is not a constant, it's varying, right? As you can see here, the value of velocity keeps on changing, which means that is the example for a non-uniform velocity. And this is also a case of non-uniform velocity. Velocity is changing, but at the same time the acceleration is remaining a constant here. And this is a retardation curve where it is again a constant value. Theta is again a constant, and it is retardation. Okay, so that is about a VT graph. Now one more thing. Suppose you have a question like this for your examination. Suppose you get a question like this. Okay, from this the terms and the values will be given. Maybe this is 5 and this is 4, this is 5 and this is 6. Maybe this is a VT graph. We know that the area under the VT graph gives you displacement. Suppose you are asked to find out the distance from this graph. How do you find out? To find the distance from the VT graph, the only thing you have to find out is find the area of this triangle, find the area of this triangle, find the area of the shape, whatever it is. If it is a rectangle, find the area. If it is a square, find that area. Then add everything up. When you add up all the areas, you will be getting distance. When you add up all the areas, you will be getting distance. And when we add up the area above the axis and we subtract the area below the axis from it, we will be getting displacement. So distance means from a VT graph, we have to add up all the areas, and displacement from a VT graph means the area which actually appears above the axis will be added up and below will be subtracted from it. So if this is A1, this is A2 and this is A3 means it will be A1 plus A2 minus A3 if you have to find out displacement. And if it is distance, we have to find out, it will be A1 plus A2 plus A3. Clear? So by finding out the area under the graph, we can either find out displacement or distance. So based on the question, you have to apply this and find it out. Okay? Distance means add up all the areas. Displacement means add up all the areas above the axis minus the area below the axis. Clear? Right. Okay, now let's move on to the next graph, and that is an AT graph. Acceleration time graph. Right? So, acceleration time graph, when we draw it, we actually consider mainly two situations. One, acceleration is a constant. Acceleration is a constant. So this is a case of a constant acceleration. This is a time axis. As you can see here, the value of A is remaining a constant. With respect to the time, it is not changing. It is an AT graph of a body moving with a constant acceleration. And remember that in the last class I taught you some ratios. I think 4 ratios I have taught you to apply in the case of constant acceleration or retardation. Okay. Now, if it is a deceleration curve means this will be the curve. If it is deceleration we are referring to, It is deceleration or retardation, and the value is negative. It's a constant retardation value. Okay, and do remember that the area under the AT graph will give you the change in velocity. Will give you the change in velocity. So change in velocity is actually equal to AT. Suppose this is A and this is T, AT, or V minus U is equal to AT from here. So from the graphical method also we can deduce the equations of motion. Okay, so the area under AT graph gives you change in velocity. Okay, so the three basic graphs I have taught you now. Now, for the examination, the graph that will come need not always be the three basic graphs. Okay, so how will you tackle if you get something else? Say for example, you are getting a graph of velocity versus displacement graph. Okay, and the graph is given like this. It's a velocity versus displacement graph. It's given for you in the question. Okay, and in the options there are 4 graphs given there, and acceleration displacement graphs are given. One graph is like this, the other graph is like this, one graph is like this, and goes on. Okay, different graphs are given. So how do you draw or how do you identify the acceleration displacement graph from the given velocity displacement graph? Okay, if it was velocity time graph, it would be easy for you. But now, how do you do this? Now, there is a general procedure for that. Okay, just listen here carefully. The first thing is first, you have to determine what is the slope of this graph. Now, as you can see here, this is actually a straight line, right? So, y is equal to mx plus c is the equation for a straight line. First of all, identify what is the corresponding slope here. It is a negative slope, which is clear from the figure. And the slope will correspond to theta, tan theta you can find out, or this theta. So tan theta or m will be equal to, tan theta will be equal to v naught by x naught. So m is equal to slope, retardation, right? So minus v naught by x naught. Okay. Now C is actually corresponding to the y-intercept, right? So what is the intercept here? It is intercepting at v naught. So we have an equation like this. Instead of y-axis, it is actually the velocity. So v equal to slope is minus v naught by x naught. Fine. X displacement x itself plus v naught. So we have the equation for velocity here. And I'm sure that you know that the rate of change of velocity is called as acceleration. And the rate of change of displacement we call it as velocity. Okay. Now, if you take the derivative of this function, we can actually find out what is the acceleration, right? So let's take the derivative. So with respect to time I'm taking. So dv by dt is equal to minus v naught by x naught, they're constants, dx by dt. Now v naught is a constant, so the derivative of v naught will be 0. Okay. Now, from this relation we can write a is equal to minus v naught by x naught, dx by dt is actually v, right? Which will be equal to, now what is v from here? So we can substitute it there, minus v naught by x naught into minus v naught by x naught x plus v naught, right? When we open the bracket up, when you open the bracket you will be getting v acceleration is equal to v naught square by x naught square into x minus v naught square by x naught. So you're getting again another equation, right? And this is of the form y is equal to mx plus c again. Here, what is the value of m? V naught square by x naught square, which means it is positive. The slope must be positive. So out of the options given there, look for a graph with a positive slope. Okay. Now, x, you know what is x. Now, v naught square by x naught plus c, it has to be plus c, right? But here it is minus, which means the y-intercept here is minus v naught square by x naught. If it is minus v naught square by x naught, the meaning is it is intercepting the y-axis at a point in the negative y-axis, which means the graph will be something like this. It is a positive slope, so the graph should be something like this, acceleration versus displacement graph. So y-intercept is over here and it is a positive slope. Okay, so if you have any option like this, something like this, similar there, then that will be the answer. Understood? So whenever you get a question like this, form an equation and try to solve this. Once you solve it, you will be getting the answer. Is it clear? Alright, so that is how you do a graph other than that of acceleration time or velocity time graphs. Okay, now let me show you a few very important graphs which can come for your examination. Let's move on to that. So the first graph I have drawn here corresponds to that of a body projected upwards. So by body projected upward means it goes up and then comes down. Okay, so in such a case the xt graph is initially given. So we know that when the object is going upward, it has a deceleration minus g, right? So as you can check here, the slope, it's actually decreasing, which means the velocity is decreasing. So till the maximum height, the velocity keeps on decreasing and its maximum height velocity becomes 0. So it is deceleration there. And when it comes downward, again the theta is increasing, which means it is acceleration. So up it is deceleration, down it is acceleration. Okay. Now the velocity time graph, this is actually a previous question. The velocity time graph for an object thrown upwards. When an object is going upwards, what is happening? The velocity is keeping on going on decreasing. And once it reaches the maximum height, what happens? The velocity increases. But when it is coming down, it is actually in a direction opposite to that of the initial direction of motion. Which means the velocity will be increasing but in a direction opposite to the initial direction. Therefore, we draw the graph like this. Okay. The third one, acceleration time graph, going up, deceleration, going down, you can take this acceleration. Okay. Now, the next is the case of the body dropped from a certain height. When a body is dropped from a certain height, we know that the initial velocity is 0, provided the body is dropped from a stationary platform. Okay. So in the previous video, we had discussed what is the condition if the state platform is also in motion, the balloon problem, right? So here, initial velocity is 0. So when the body is coming down, it will be accelerating under acceleration due to gravity, and the velocity will be increasing, which is very clear from this graph, xt graph. Okay. And the velocity again, it is increasing, right, which is straight away shown by this graph, a vt graph, and acceleration will be positive, a t graph gives you that. Okay, so make sure that you learn the graphical method because you can actually expect one question from here. Like I told you, it need not be always a direct question. It can be a question like we are having given an acceleration displacement graph or a velocity displacement graph. I told you that in the previous question, if a velocity displacement graph is given, find the slope and then differentiate it to find acceleration displacement. Now suppose in the question it was an acceleration displacement graph given and we were supposed to find out velocity displacement relation. Then, we will have to take the integral of the function. Our function the integration and you will be obtaining the answer. Okay, so we have to integrate the acceleration equation, then you will be getting the corresponding velocity displacement graph. Okay, so I hope it is clear. The graphical motion representation, anything doubt, please do comment below. I'll be doing some questions related to this, related to graphical approach and the one-dimensional topics, and also about relative velocity concept. Aduna relative velocity concept I have not discussed in the previous video. I'll be doing separate topic videos on that. So I hope you have understood this. In case you have any doubts, feel free to comment below and do subscribe to the channel and do share the channel among your friends. Okay, thank you.